Here's the problem. The more we use computers, the more energy is required. In fact, computation accounts for around 10% of global electricity use.
It's doubling around every decade. Eventually, it's going to be too much.
Professor Michael Fuhrer is a world-renowned physicist looking for ways to compute with lower energy.
Some of that energy is hidden from us. A smartphone in our hand isn't necessarily using so much power in the device itself, but we're typically accessing information from the cloud. We might be chatting with ChatGPT. So we're using some computing resources that are out there somewhere, and they're in server farms. They're in these big facilities full of computers that use vast amounts of power, both to run the computers and to just keep them cool.
Professor Fuhrer is director of the ARC Centre of Excellence in Future Low Energy Electronics Technologies, or FLEET. One of FLEET's priorities is to find a replacement for silicon, which serves as the building block for computer processors.
Transistors made today don't look exactly like the ones that were made 50 years ago. And ultimately, I think we're going to need a new material that's not silicon and really a new principle of operation. So those transistors, those switches that actually do the computations, I think we'll have to work on a different principle to use less energy.
His team is looking at a new class of materials called topological insulators. Their bulk is insulating, but their surface is conducting. They're sometimes compared to a block of wood wrapped in tinfoil.
We think those materials actually have the ability to switch on and off with lower energy than silicon, and so that's a good candidate. But the actual material that would be used is yet to be made in the lab.
He cautions against expecting overnight results. A lot of the research undertaken by FLEET is fundamental. It's familiar territory for Professor Fuhrer. He spent much of his career studying graphene, a single layer of carbon atoms arranged in hexagons. His groundbreaking work enabled us to better understand how electrons behave in graphene, leading to improvements in devices based on the material. Raised in Texas, Professor Fuhrer moved to Australia at the invitation of Monash University, and it was here that he discovered a new passion while riding his bike to campus.
One day a purple swamp hen walked across the path and I said, "What is that? It looks like this little purple dinosaur."
During the COVID-19 lockdown, he spent time photographing birds in his local park.
I just got very used to taking photographs of birds in the same place, and then I'd take a photograph and I'd say, "This is really good, but I know I'm going back next week, and I think I can do a little better."
In other words, a very similar approach to that which this new fellow of the Australian Academy of Science applies to his research. It pays to be patient.
You can do the same thing, have to do it many times to get it to work. But when it does work, it's fantastic. You get to see something new that nobody's seen before. It's a thrilling feeling.